A fantastic structure in space, so huge that it influences the orbits of entire clusters of galaxies, is also attracting us on Earth right now. Our entire galaxy is being inexorably moved by this gigantic thing called the Great Attractor, and we don't know why, and we don't know how this journey will end. At the moment, there are a lot of unanswered questions about the Great Attractor. All we know for sure is that it is one of the most powerful phenomena ever found in space. It may be an immense collection of intergalactic gas and dark matter, which together generate a gravitational force of unimaginable proportions, or it could be an as-yet unknown cosmic object whose true nature and properties will add a new dimension to our understanding of the universe. Imagine looking into the universe and suddenly seeing a huge thing, so huge that it's one of the biggest things you have ever seen. The Great Attractor has been located by scientists in a region of space known as the Norma Cluster, or AEL 3627. This cluster lies at the center of the Lanaka supercluster, a gigantic collection of galaxies that includes our Milky Way. If you want to get a rough idea of where the monstrous something is located, you need to look near the constellation Norma. This constellation in the southern night sky is rather inconspicuous, but you can find the Norma constellation if you first identify the well-known Scorpio and Sagittarius in the sky. The constellation of Norma lies between these two more conspicuous constellations to the south. It is very difficult to see with the naked eye, especially within cities, as it does not contain any particularly bright stars. So, between Sagittarius and Scorpius, you can imagine the Great Attractor, a massive gravitational anomaly that very likely affects the overall motion of galaxies within the Lanaka supercluster. This anomaly is located at a distance of about 150 to 250 million light-years from Earth. The exact position of the Great Attractor is difficult to determine, even for astronomers with the best telescopes in the world, because the attractor lies behind the Milky Way band, a dense region full of stars, dust, and gas that limits visibility. Researchers call this area of the sky the zone of avoidance. Its location behind the band makes direct observation of this phenomenon extremely difficult. Nevertheless, we know it is there. The effects of the Great Attractor are hard to miss. The Norma cluster most likely forms the core of the Great Attractor, as a massive collection of galaxies. The cluster exerts a significant gravitational force. It is estimated that the Great Attractor has a mass of about 10 to the power of 16 solar masses. This suggests that the Great Attractor may be much more than just a massive collection of galaxies. The galaxies could just be the visible effect of the actual force behind the attractor. Due to its enormous mass, the attractor has such a powerful gravitational pull that galaxies, hundreds of millions of light-years across, are affected, including our Milky Way and the Virgo galaxy cluster. This discovery raises questions about what role the attractor plays in the grand cosmic theater. Is it random, or does it perform a very specific function, the further connections of which we have not yet understood? Scientists suspect that the Great Attractor may conceal a previously unknown force in the universe. But what is it that forms such a massive gravitational source? Is it an ultramassive black hole, whose gravitational field is so strong that it casts a spell over entire clusters of galaxies? Or could it be a colossal collection of intergalactic gas and dark matter, which together generate a gravitational force of unimaginable proportions? What exactly is the attractor? It's a fantastic idea that somewhere behind thousands of galaxies and trillions of stars, there is a thing that is constantly casting its spell over us. We have known for several decades that a supermassive black hole is hidden in the center of most galaxies, and that these black holes are responsible, among other things, for the movements within the galaxies. Their suction force also forms something of an attractor inside the galaxies. Black holes constantly attract matter, and if it's close enough, it falls under the black hole's spell and never gets out again. It's a scary idea that the Great Attractor could be a much more powerful black hole, potentially sucking in entire galaxies, and we are moving inexorably towards this phenomenon. Scientists currently believe it's entirely possible that a supermassive black hole at the center of the Great Attractor is the source of the enormous gravitational force that is setting entire clusters of galaxies in motion. The structures that can be found at the galaxy level could be found on an even larger scale in the cosmos. However, the idea of an ultramassive black hole at the center of the Great Attractor also raises questions about how such structures are formed and what mechanisms make such an accumulation of mass possible. Another widely accepted theory is that the Great Attractor is an enormous collection of galaxies, intergalactic gas, and dark matter. These components together could generate a gravitational force of unimaginable proportions, similar to that thought to exist in the Great Attractor. Dark matter, which makes up around 85% of the total mass of the universe, plays a decisive role in this theory. Dark matter is still one of the greatest mysteries of the universe. It is not directly visible but influences the movement of galaxies and galaxy clusters. A particularly high concentration of dark matter in the Great Attractor could also be a very good explanation for the observed gravitational effect. In this case, the Great Attractor would be a kind of massive galaxy cluster or mega-supercluster, whose true nature is currently still obscured by dark matter. Regardless of which theory is correct, the Great Attractor has immense implications for our understanding of the universe. We are only at the beginning of exploring the large-scale structures of the universe and the dynamics of galaxy clusters. The Great Attractor could play a key role in understanding the entire cosmos and provide us with completely new insights into the nature and distribution of dark matter. Researchers are currently working on observing the Great Attractor through the zone of avoidance. Advances in telescope technology and astronomy will give us a clearer picture of this enigmatic phenomenon in the future and hopefully help us uncover all the secrets of this fascinating discovery. The Dipole Repeller. There's an even more powerful force, the Dipole Repeller. The incredible discoveries in the vastness of the cosmos just keep on coming. This is because researchers have identified a counterpart to the point of attraction, the Great Attractor, which acts as a cosmic repeller. The counterpart is called the Dipole Repeller, and this phenomenon has only recently been discovered. Fascinatingly, this repulsion anomaly is the perfect counterpart to the Great Attractor and is probably also a key element in understanding the motions of our local group of galaxies. The Dipole Repeller is located at a distance of about 450 million light-years from Earth and lies in a direction almost opposite to the Great Attractor. It is not a physical object like a cluster of galaxies, but rather a large region of space with a very low density of galaxies. The repeller could also be described as a large void, but it probably isn't really. Unlike the attractor, it only has very few galaxies, but some kind of structures and forces must also be present in the Dipole Repeller. The enormous repulsive force is caused by the subdensity. This effect means that galaxies are simply pushed away from this region in a completely different way than the attractor. This cosmic oddity was discovered during research into the movement of galaxies. Scientists use data from the cosmic microwave background radiation and from the distribution of galaxies to map the gravitational forces acting on the Milky Way and its neighboring galaxies. This region of extreme repulsion stood out, and scientists were amazed. The discovery of the Dipole Repeller was surprising but also revolutionary, as it helped to clarify a previously unexplained component in the motion of the local group of galaxies. The existence of the Dipole Repeller sheds a whole new light on the complex structure of the universe, and this discovery will help us to better understand the role of dense and empty regions on a cosmic scale. These dynamic interactions between attraction and repulsion in the large-scale motions of the universe could also shed light on how the universe is structured and what forces, perhaps previously unknown, are at work in this cosmic network. A gigantic void. It is the repeller, a gigantic void. The question arises as to what exactly the Dipole Repeller is. The prevailing theory is that it is a huge region in space characterized by an underdensity in the cosmos. Heavy objects attract others, and where there is less mass, objects tend to be pushed away. The Dipole Repeller is certainly not a physical object in that sense, but rather an area of space where the gravitational force is weaker than in the surrounding, more densely populated regions of the universe. Some scientists speculate that the Dipole Repeller, like the attractor, may be connected to dark energy, and this is what makes it so exciting. It could be that dark energy is more dominant in regions such as the Dipole Repeller, leading to a repulsive effect on surrounding galaxies. In the case of the attractor, on the other hand, an effect of dark matter is suspected. dark matter and dark energy are among the most mysterious factors in the universe. The Dipole Repeller could also be compared with other known cosmic voids. These voids are gigantic areas in the universe where there are generally very few galaxies. They are part of a large-scale network of galaxy clusters and voids that structure the entire known universe. The Dipole Repeller could be a particularly pronounced void, whose gravitational effect is strong enough to influence the motion of neighboring galaxies. A cosmic network. It's amazing, but in many ways, the universe resembles a living organism in its structures and composition. The interplay between the Dipole Repeller and the Great Attractor, the shapes of the galaxy clusters, and the superclusters and regional groups surprisingly do not show the spherical, spiral, disk, or vortex shapes that otherwise predominate in the universe. These structures appear organic, almost chaotic. Here we seem to be on a completely different level of the cosmos than when we look at the harmonious geometric shapes of the galactic plane. Research into the fundamental structures of the universe is still in its infancy. The phenomena of the cosmic repulsor and the attractor are promising new leads in the puzzle of the actual structure and true nature of our universe. The universe is an immeasurably large and complex structure based on a gigantic network of galaxies, galaxy clusters, filaments, voids, and other cosmic formations. This network that we see today is the result of billions of years of cosmic evolution. We will probably only understand the full complexity of the universe once we have a better understanding of the two great unknowns, dark matter and dark energy. Together, they are said to make up around 95% of the universe. In practical terms, this means that we hardly know anything about most of our universe. So far, we can only observe visible matter and its dynamics. Due to the effects of the dark aspects, we know that both must be there, but we can neither measure them nor observe them directly. Dark matter, which makes up about 27% of the universe, is probably crucial for the formation and stability of galaxies and galaxy clusters. Dark energy, which fills about 68% of the universe, counteracts gravity and is thought to be responsible for the accelerated expansion of the universe, among other things. Researchers have discovered huge filaments of dark matter and intergalactic gas between the galaxy clusters. These filaments form a fascinating cosmic network that runs through the universe like a nervous system. Subscribe now and be part of every new video.